Python is a general purpose programming language that is quite easy to learn. It is line structured and uses indentation to separate blocks of code, resulting in highly readable code. It has a clean syntax and it's an interpreted language. It's designed by Guido van Rossum and it is quite popular because of its ease of use and the availability of large number of libraries for applications like networking, graphics and scientific computation. There are two ways to use it. Suppose let us open a terminal and we can start the Python interpreter just by typing Python from the terminal. So here this triple angle bracket says you are inside the Python interpreter. So here I can type any Python command, like say print hello. It prints that. Or you can use it as a calculator like this, or even you can define a variable, say x is equal to 5 and say print x inverse. But it becomes a little bit difficult for larger programs. Then it is easier to have a text editor and you type your programs in the text editor. Open a new document and say print hello. We save this file and we'll save it in a file called give it some name, say 1.py. So give this .py extension, saved. So once you give this .py extension, the syntax highlighting appears because the editor is aware of the Python language. Now you come to the terminal, come out of the interpreter by pressing Ctrl D and to run the program say Python 1.py. It prints hello. Now we will be learning it by modifying this program. Let's say we define a variable x is equal to 10, so print x. Again run it. No, we didn't save it. So save this and run that. Now the question is, what is the data type of x? Like in Fortran or C or any other programming language, you have to mention the data type of this variable in advance, but we have not mentioned anything. So let us ask the interpreter what is the type of x. Save this and run it again. It says x is a integer. Now we go back and make it say 10.0. Save it again and run it. It says it is float now. So that means the data type is decided by what you assign to it. This is called dynamic typing. So Python is a dynamically typed language. So I can change this into something else, say complex number, save this. See, it has become complex data type. So we have seen three data types of Python already: integer, real and complex number. Now let us put few characters inside single quote or double quotes. Save this and print. So this is another data type called string. But if you see, there is a difference between string data type and other three. String is a collection of identical elements. You can see here there are 5 characters. So what you can do is you can do something like this, an indexing here on the string data type, this, or you can say x1. Let's see what it prints. You can see the indexing x of 0 print the first character and the second one and so on. So this is the difference between a numeric data type and this collection type. Now we'll go and see another data type in Python that is quite important for us. Something like this. Inside a square bracket we are putting a list of variables, say 3 of them like this. I will say print type of x, say this. It says a list. A Python list can have any type of variable in that, and the list is quite flexible. You can add elements to a list, remove elements, and reassign the value of a list and such things. Say for example you print x here. Now you say x of 1 is equal to 100. Then again print x. You have to save it. See here, this element has changed because we have done it here. But this is not possible with a string. That means string is immutable, but list is mutable, as you can change the elements later on after defining. But string, once it is defined, you cannot change that. So we have seen some basic data types of Python, say 4 of them. Now let us write a program. Say if our objective is to write a program for, say, printing the multiplication table of some number. So I want to print the multiplication table of 5. Say I can do something like this: x is equal to 1, print x star x into 5. Then say x is equal to 2. Save this and let's see what it prints. So it is printing the table of 5, but it doesn't look like a good way of programming. And you also notice that the interpretation starts from the first line and goes line by line, right? So program is running the order in which we have written it. But we don't want this most of the time. We want the programs to take a flow depending upon some conditions. So if you have seen, whatever we have learned so far is how to define variables and how to do some arithmetic operation, and we can also do logical operations on that. And Python supports a large number of operators. Let us take one more example just to show. Say x divided by 5. So here you will notice one more thing. It is 0. Why? Python is doing an integer division because x is an integer. So if you want to make it a floating point division, it's a decimal, put it like this and run it again. Now you get the correct answer. So you have to be very careful to avoid such situation. If you want a decimal division, don't define the variable as an integer. Let's have a look at the operators in Python. Here you can see a list of operators listed according to their precedence. And here we have the 4 arithmetic operators: multiply, divide, and this remainder function and addition and subtraction. And then there are bitwise operations, bitwise OR, XOR, and so on. Then comparisons are there, and also other operators. And you also have to see the precedence of the operator. So let us take an example like this. Say x plus 5 into 3. So what do you expect out of this? The result, let us examine. So here you can see that this is performed first, then this addition is performed second, because as per the precedence rules this has more precedence than this one. But you can always change that by putting parentheses. Suppose if I want the result to be x plus 5 into 3, I can make it like that. Now if you run it, see, the result is 6 into 3. So if you want to control the way in which is evaluated and or to enforce the precedence, use the parenthesis operator. And now let us see the logical operators. Say y is equal to 2, x is equal to 1, y is equal to print x is equal to y. So this is a comparison. And remember, this equal sign is not equality, that is assignment operator. This means assign a value of 1 to x, and this means a comparison. So what it will print now? It says false, that means x is not y. But if I make it say something like this, it's true, because the test is whether x is not equal to y or not, and that is true. So what you are saying is the program execution goes from first line to last line in a monotonous fashion. And now we want to change that, because what we have learned is how to define variables and how to perform arithmetic and logical operators on that, and that is not sufficient. You need control flow statements. That means depending upon the value of some variable, the program flow should change. Like suppose put it like this, x is equal to 1, and I should be able to write something like, if x greater than 2, you put a colon, then you say tab, say print big, right? Else is not a must, you can have an else also, else print not big. So here you will see, depending upon the value of x at this point, either this will be done or this will be done. Let us save this and run it. It says not big, but now if I change this to 5, save this and run it, it's big. Probably you can modify this slightly. Instead of assigning it like this, let us take it from the user. We can use a input and then run it. Now it is waiting. This blinking cursor means it is waiting for something. So I would say, I'll put something like 3 here. It says it's big, but we don't know what it is waiting for. So we can do some prompt message here. Say enter number, put a string here. Now save it again. You can see the prompt. You can enter the number. So we have written a Python program having a conditional operator. You can also test multiple conditions, like if x is x greater than 2. Now after that put say elif, that means it's a short form of else if. Else if x is equal to 3, print say same. Else print not big. We'll save this and run it. We'll enter 3. Is printing big. Why? We entered 3, but this statement is not even encountered, right? So the reason is, first it tested for this and this is found to be true. If this is true, then it will not evaluate other things. So here we should modify this, say x greater than 3, then run it again. Now if you print 3, say same, because this test failed here, the first testing, then the second one succeeded. If that also fails, then this will be printed. Say if you enter a 1, so that means when you x is 1 here, this is not true, this also not true, then it took this path. So this is how you use the if statement: if, elif and else. So now the conditionals are explained. The next important control flow statement is iteration. That means you repeat a block of code many times. So here you can see this block of codes in Python are mentioned by indentation. So probably I'll explain it again. So put one more statement here. Say print x. Now run it again. You can see these two statements are executed. So what decides that? That means these two, see, both are indented, right? So the blocks of code are separated by indentation, either by a fixed number of spaces or tab, but never mix tabs and spaces, and that will give a error which is difficult to find out. The interpreter will get confused. Now the syntax, all you have to remember is, whenever there is a block of code, indent that, and before the indented block always there will be a colon. So colon is the most important thing you have to remember. Anywhere you have an indented block, the previous line will end with a colon. Now let us go for the iterations. While x less than 10, print x. The while loop works like this. So long as this condition is true, this will keep on executing. But inside the loop somewhere you should have a statement that will make this false. Otherwise it will result in an infinite loop. Let us run that first. Python. I'll write, say first I'll write 15. Nothing happened because this test failed in the first test itself. Run it again. Put 3. It keeps on printing 3. Now the way how to come out of this, press Ctrl C. So you have broken that execution, and now let us add one more line here to modify x. Say x is equal to x plus 1. And remember, this is not equality. What you are doing is take the present value of x, add 1 to that and assign it back to x. That means incrementing x by 1. Now what will happen? After a while this condition will automatically become false and the program will stop. we entered 5 and up to 9 that condition was true, it printed, but at the moment it was 10, it ended. So then it is jumping here. So we can add one more line here to show that. Say print done. Save. Right. So this is another control flow statement, that is while loop. So we have seen the following now. We learned how to define a variable in Python, and we have seen the variables like the data types like integers, floating point numbers, complex numbers, string, and list data types, and also covered the arithmetic and logical operators, some of them. And most important thing is we learn two control flow statements, that is conditional statement if and the loop construct while. So basically now the language, you can say, it is complete. Any problem can be solved with these features if the language has this whatever features which you have explained. The most important thing is the ability to do conditional statement and iteration. The remaining things are to make the job easier. Python also has a for loop for iteration. It works slightly different way. Suppose say I have a compound statement, say compound variable, a collection type variable. Hello, it's a string. I can do something like for say k in x. This is the syntax of for loop. Print k. Let's see what it prints. It is printing all the characters. So how it works is, this k is called the loop variable. So in each iteration, the members of this data type are assigned. Say the first go, h is assigned, and second time the loop is executing, the second this member is assigned to k. So k is assigned with a value that is different in each run. Probably we can use a list here and do the same thing. See, we have a 4 element list, and do the same with this. There is a mistake somewhere. You know what is a mistake? See, this is one advantage of Python. The mistake, whichever line, it will just put a mark here and point out the line where the error has occurred. And the syntax highlighting also helping us here. You can see here there is an integer, a floating point, and there is a complex number, but apparently there is an unwanted single quote there. So remove that. And we'll run it again. Save. It is listing all the 4 elements of the list data type. So this is how the for loop works. And if you want a for loop to go from say 10 times, so there is an easy way to do that. That is, you use the range function. Say x is equal to range 10 and print x, and also we'll run the loop on x and see what happens. here this is x. So this range function, range 10, makes a list of 10 elements as 0 to 9. And range function you can only specify the number of elements required. Then it goes from 0 to this -1. That means the step is 1, starting point is taken as 0. But you can specify that also. Suppose I want to go from 5. Now the starting point and end point plus 1 is specified. You can see here. We started with 5 and went to 10 minus 1. You can also specify the step. See, after 5, next is 7 and then 9. So start point, end point plus 1 and step. So if you want a for loop with a fixed number of iterations, use the range function. So now we know how to write programs for some useful purposes. Now let us say we want to write the multiplication table of some number. We can write it like this. We define a variable, put it as 1, and say while x less than, say put less than or equal to 10, colon, print x into 8. So we want multiplication table of 8. Then 1. So x is equal to x plus 1 can be shortened like this. This is a shorthand notation. Or if you want, you can write it like this also. Save this. So you have the multiplication table of 8 printed here. So it's quite easy to do something in Python. Now if you look at it, suppose say our program is growing like this and you have a 1000-line program, then it is difficult to manage something like starting from here and then going up to 1000. Then you should be able to break it down functionally. That is where you need something called functions. You should be able to define a function. Let us take an example. So how to define a function? The keyword is def. So give some name, that is something called some odd function. We can just put it something like say special add, some addition. Two variables. So our function should add x and y in whichever way we want. Say we will say a is equal to 3x plus 5y and return a. So this is what our function is doing. It's only a template. Sometimes each function will have maybe several lines or sometimes bigger. Now let us run this program and see what happens. Nothing happens because we just defined a function but we didn't call that, so it's not executed at all. Now you have to add something like this. You can see what it does is 5 into 3 15 plus 5 into 3 15, right? So get 30. The variables are taken in the order in which they are assigned. Like the first variable is x, so whatever you put here first, that will go to x. Whatever second, that goes here. Python also supports some more flexible ways of named variables and all. We will not go into that now. So now at least you know how to define a function and how to call that. but most of the time we will be using functions written by others, and let us try that. Suppose I want to do the mathematical operation sine 0.5, say print sine point. Now you will get an error message. It says name sign is not defined. What you can do is you have to import that library that contains sine function. There are many ways to import libraries. I'll first use import math. In that case, you cannot simply write sine. You have to say math dot sine. That means sine from math library. That is the dot operator here. Huh? Math dot sine. It gives the result here. But suppose if you don't want to write this math dot every time, there is another way to import it. You import it as a local function. That is from math import sine. Now you don't have to put this. Simply say like this. Right? But now if you want to cos, then again you have to write that. So it's better put a asterisk there. Wildcard, import everything. Now I can have sine or any other function, right? So this is how you use a library. We have seen some basic features of Python, and we'll continue with other things like graphics libraries and all later.